So, in case of theory of pharmaceutical suspensions, the sedimentation behavior of flocculated and deflocculated suspensions, now we are discussing in these topics. At first, we have to know what is flocculated suspensions and what is deflocculated suspensions. Now, previously, we have, please have a scene. Previously, we have already thought that suspensions classifications, the they are suspensions are classified based on their electrokinetic nature of solids, particles, flocculated suspensions, and deflocculated suspensions. So here, first, based on the proportion of solids, suspensions are empirically classified as a dilute or concentrated systems. Dilute suspensions may contain about 2 to 10% weight by volume solids. Examples are cortisone acetate and prednisolone acetate, and concentrated suspensions contained solids as high as 5 uh, 50% weight by volume. Examples are zinc oxide suspensions for external use and procaine penicillin G suspensions as an injections. In general, depending on the nature and behavior of solids, suspensions are classified as flocculated and deflocculated suspensions. It is essential for us to identify a particular type of suspensions from its appearance. The distinguishing characteristics of these systems uh, we're now discussing the deflocculated suspensions and flocculated suspensions. So, deflocculated suspensions, in this system, solids are present as individual particles. There also exhibits aggregations, but comparatively at a slower rate than the flocculated particles. These systems have a shorter shelf-life but have greater bioavailability when compared to flocculated systems. Okay, and in case of flocculated suspensions, in these systems, particles aggregate themselves by chemical bridging. These flocks are tight, light, fluffy conglomerates which are held together by van der Waals forces of attractions. Aggregations is achieved by adding flocculating agents. For instance, by the addition of more anions onto a positively charged deflocculated particles, flocculation can be achieved. This system possesses better physical stability characteristics, but its bioavailability is less when compared to deflocculated system because the dissolution of flux is a prerequisite for drug absorption. Is this clear to all? That in case of deflocculated suspensions, this system have a shorter shelf life but have a greater bioavailability when compared to flocculated systems. And in case of flocculated suspensions, sorry, its bioavailability is less when compared to deflocculated system because of dissolution of flux is prerequisite for drug absorption. But this system possesses better physical stability characteristics. So, in this case, we can differentiate these deflocculated systems and flocculated systems. For deflocculated systems, the appearance is pleasant because of uniform dispersion of particles, but in case of flocculated systems, somewhat unsightly sediment and clear supernatant layer. For deflocculated systems, supernatant remains cloudy, and for flocculated, supernatant is clear. For deflocculated, particles experience repulsive forces. For flocculated, particles experience attractive forces. For deflocculated, particles exist as separate entities. For flocculated, particles form loose aggregates. For deflocculated, rate of sedimentation is slow as the size of particles are small. But in case of flocculated systems, rate is high as flocks are the collection of smaller particles, the higher size. For deflocculated systems, particles settles independently and separately. But in case of flocculated systems, particles settle as flocks. For deflocculated systems, the sediment is closely packed and form hard cake. For flocculated system, sediment is loosely packed, network and hard cake cannot form. For deflocculated, as the hard cake cannot as the hard cake is formed, it can't be redispersed. But for flocculated system, sediment is easy to redisperse by mechanical shaking. For deflocculated system, in the potential energy curves, it represents the primary minimum. But for flocculated system, the potential energy curves, it represents the secondary minimum. For deflocculated system, bioavailability is relatively high, but for flocculated system, bioavailability is relatively or comparatively less. So, is this clear to all? Uh, the differentiation or the difference between the deflocculated and flocculated system? So here the flocculated suspensions flock will cause increase in sedimentation rate due to increase in size of sedimenting particles, and sediment is more rapidly formed. Suspensions, the flocculated suspensions, the loose structure of rapidly sedimenting flocks are appeared. The volume of final sediment is thus relatively large and easily redispersed by agitation. For deflocculated suspensions, individual particles are settled. Rate of sedimentation is slow, difficult to redisperse by agitation. This is also called claying or cracking. And large particles settle first, and small particles remain the supernatant liquid. Here we can see the differentiation between the flocculated and deflocculated suspensions. The period of standing for short period time, flocculated is clear supernatant area, and these are the flocks. And for deflocculated, as the sedimentation rate is high and for this is slow, so no much changes in initially. And medium period, porous sediment large porous sediment is formed and the supernatant is clear. It is this slightly hard cake has formed, and this is sorry, and too much changes not seen. And for a long period, a little change in sediment volume, but these things is remain clear, and hard cake is formed and the supernatant is not clear.